Hi and welcome. I'm Hank Preston, a developer evangelist with Cisco DevNet, and today I'd like to talk to you about how to be a network engineer in a programmable age. This is the introduction to our Network Programmability Basics course, and today we're going to start off with a discussion of the network engineer of old, where we've all come from. We'll explore the 4 ages of networking and how cloud has come into the journey with us. We'll look at today's network engineer and the skills required and how the Network Programmability Basics course can help you accelerate your journey. To get started, let's look back at the network engineer of old, where we've all come from, where our field is coming out of, and how we need to transition. To do that, I'd like to introduce you to Carl, the network engineer. Carl is a network engineer's network engineer. He has a load of networking skills that have made him very successful up to this point. He understands layer 2 concepts like spanning tree. He's got layer 3 areas down with routing protocols, quality of service, security with VPN design, new applications like voice over IP, and spanning tree. He can handle spanning tree like the back of his hand. With security policies and MPLS, he has got all of his networking skills under control. But he also does have a few programming skills. Along the way, he's had to pick up tickle scripts and embedded event management, and also using expect scripts to automate some of the network configuration. Now, this skill set has suited Carl very well, as the network started looking like this when he got into the industry. He had routers and switches, and servers connected to his switches. We can all remember when the network looked like this, and it was simple. We could walk into our data centers or our closets, and we could touch our network. It was likely painted teal green with Cisco silk screened on the front of it. But over time, the network started to evolve, right under Carl's nose. The first hint of it were these guys, the V-switches, virtual switches and virtual machines. Well, at this point, Carl and the rest of his network engineers, they looked at it and they said, virtual switches, V-switches, that's not real, that's software. We'll let the server guys handle the V-switches. Nobody's ever going to put anything of critical importance in a virtual machine anyway. We'll stick with the routers and the switches, the important network up here. Well, it didn't stop with the V-switches. Before long, Carl's network had blade switches connecting into it. And now he was even farther away from the servers that he was worried about. Well, in this case, the blade switches often came from server vendors and on server bills of material. So once again, Carl and his fellow coworkers said, you know what? Let the server team continue to deal with those. The real important networking are the routers and the switches, and we'll focus on that physical network that we can see and touch. Well, it didn't stop. Later, we had LBRs and containers. The LBR is the Linux bridge, and now we have networking concepts happening inside of virtual machines, really quite far away from the routers and switches that Carl was used to managing. Then we have cloud, and cloud picks up. With cloud, we have cloud exchanges and connectivity between our data centers and our cloud. But worse than that are all the virtual machines that don't have any physical network at all, or containers connected directly to cloud, and then all the as-a-service elements. Well, the network continues to evolve from there, and let's not forget all the network services and appliances and capabilities. Load balancers, firewalls, IPSs, lions and tigers and bears. There is so much into the network today that we have to deal with. And Carl and his fellow engineers, me, yourself, everybody watching, we have to accept it. Let's calm down for a minute. We'll resettle ourselves with an old friend, the OSI model of networking. I know you all remember the OSI model. We've had to memorize this. It was on our certification test back when we were studying for CCNA. Layers 1 through 7, and we memorized mnemonics so that we could get our way through physical all the way up to application. But let's be honest with ourselves. There's really only 3 layers to the OSI model. In the middle, we have the oh yeah, we got this layer. MAC addresses, IP addresses, TCP and UDP ports. We understand that part of the OSI model. But above and below it, we have the black magic layer, the physical layer of electrical connectivity and link layer areas, and how do we deal with fiber versus ATM and all of these other areas that go through. Physical layer is tough. Not to mention we have the please don't ask me about this layer where we've got session, presentation, and application. Heck, it's got application in the name. That's clearly not something we want to deal with. Well, frankly, this is just as much of a challenge as the elements that are part of a network topology. We have to understand all 7 layers of the network today. Applications running on the network are reliant on us understanding and making sure protocols like HTTP function appropriately. And session consistency across these applications are becoming important in this space. We can't focus solely on layer 2, 3, and 4 anymore. This transition, I like to call it, through the 4 ages of networking. We started back in the Stone Age, where the only things we've really had to worry about were spanning tree and VLANs. Right? We had spanning tree because we want redundancy in our network. We want to make sure if there's an outage, our network will continue to go. But it was okay that it took 45 seconds to a minute for convergence because nobody really cared that much. And then in the VLAN discussion, all we really had to decide is whether we were going to put our printers on the same network as our computers. And most of us took the easy way out and said, yeah, we can put them all on a single VLAN. The Stone Age was around for a while, but we did end up in the Bronze Age, when we had the .com era came through and everybody had WAN designs and campus topologies that had to be dealt with. We layer 3 concepts for routing protocols and making decisions between EIGRP and OSPF, or maybe even RIP. Is that simple enough? WAN design architectures, but honestly, many of us just relied on our service provider partners to help us design the proper WAN and control that. But in the Bronze Age, it ended with IP-mageddon, the exhaustion of IPv4 address space. And we all had to turn to IPv6 and double down and focus and make sure we dual stacked all of our networks. And I know every one of you have a dual stack network today, right? Yeah, not quite. Well, coming out of the Bronze Age, we get to the Renaissance. In the Renaissance, we had this rebirth of networking concepts. Software-defined networking kicked off the Renaissance and brought us concepts like OpenFlow and controllers, overlays, multi-protocol BGP. I gotta be honest, that one scared me a little bit. I thought I had a handle on BGP and then they throw more than one protocol at it? Whew. And then VXLAN. Well, back in the Stone Age, we had VLANs and we needed a new network segmentation for the Renaissance. So we did what we always do in the networking. We put an X in the name and we have VXLAN, the segmentation for the modern age. Well, the Renaissance was quick, it was active, it brought us a ton of concepts, but we didn't stop there. This brings us to the programmable age. And in the programmable age, the impact of cloud is really hitting us. We're starting to see Python become a new language for network engineers and infrastructure automation. APIs for the network, be they REST APIs or the new standards of NetConf and Yang. We're designing fabrics. We have DevOps and containers, all of these things to deal with. But why? Why have we had such a rapid change across from the Stone Age to the Bronze Age and Renaissance and programmable age? Well, for me, it comes down to the digitization of the enterprise and the changes that our businesses are all having. The app economy, user expectations are requiring a much higher degree of agility across our enterprises than we've had in years past. The Internet of Things, or as I like to call it, if it isn't connected, don't even bother, is affecting and putting pressure on networks and design, whether it's scale and topology or security that we have to address around the IoT era. Then we have the tech unicorns putting pressure on every one of your enterprises out there. The barrier of entry to disrupt traditional enterprises is lower than ever. Anybody with a credit card and a great idea can challenge all of our organizations. These challenges are pushing down on our lines of business, our CIOs, the CTOs, the CEOs, trying to figure out how do we solve these solutions. And technology is part and parcel to all of this. And we know how we've decided to solve it. Every one of your organizations, I'm sure, has turned to the cloud because the cloud will repair all of these issues. They'll make our app economy woes go away. It lets us connect to everything. And those tech unicorns can't stand a chance because we can sprinkle cloud fairy dust over all of our problems. Well, if you've gone through any of these, and I'm sure you have, you know that everybody sets out with the plan to build the unicorns of cloud. They'll be powerful, they'll be beautiful, they'll work exactly as we're after. Well, the challenge is cloud and building clouds is not a simple activity. There's more to it than just going ahead and taking what we've always done and adding some extra software or interfaces. In fact, rather than getting unicorns, often we end up with donkey corns of cloud. They kind of look like a unicorn, but not really quite there, and nobody's quite as satisfied with a donkey corn if they were expecting a unicorn. You may be sitting out there and feeling a bit angry, right? All of this coming at us. Why such acceleration? Why do I have so many new technologies and languages and APIs to go through? And you're just feeling frustrated. That's okay. If you're feeling frustrated, that means that you've moved beyond denial. I used to have conversations like this, and I'd see network engineers and folks just shake their head and say, Hank, you're crazy. I don't need to worry about automation. We're plenty fast enough. I'm happy with my CLI. I don't need APIs. Well, if you're at anger, that's great, but we can't stop there. What I'm trying to do is help people move beyond anger and get themselves to acceptance. Because it's in acceptance where we can tackle these challenges and really ground ourselves and move forward into today's network engineering. Speaking of, let's talk about what a network engineer of today looks like. Going back to the start of this session when we discussed Carl. Well, Carl was confronted with all of this just like you have, and he came up with a three-phase approach, a way to break down all of this stuff coming at him in a consumable fashion. In phase one, he left networking aside for a second and focused on some core programming skills, some Python and APIs, learned about data formats like JSON and XML, and started experimenting with source control in Git and GitHub. With that under his belt, he looked to Linux skills and Ansible, and maybe toys around with Docker and some of the new networking protocols like netconf and Yang in phase two. And then finally in phase three, he can double down into Linux networking, container networking, network function virtualization. And then as needed, be sure to pick up all topics like controllers and IoT. If you work in the manufacturing space and IoT is important, there are all sorts of protocols and wireless and mesh and gateways that you'll have to understand and pick those up as required by your job. Now, with this plan in place, Carl embraced programmability, and I know you can too. He even got himself a new shirt. He's added new networking concepts like these APIs and controllers, cloud and Linux networking, IoT. But along with the networking pieces, he's picked up all these core programming skills. He's solid in Python. He understands how to interface with REST APIs for all of the surrounding ITSM systems and other platforms. His Linux skills are sharper than ever, and he's leveraging Ansible or Puppet and Chef across his network for configuration and leaving behind the expect scripts of old. Now you may be thinking to yourself and saying, that's great, I'm happy for Carl. It's a sharp new shirt. But what about me? I feel like I'm still back here in the Stone Age. What am I supposed to do, Hank? Well, if you're watching this video, you're in luck because that's what this whole course is about. The Network Programmability Basics course is about helping you jumpstart your journey into network programmability. We've broken up this course into core modules that tackle across the areas to get you a solid foundation so that you can dive in across automation and concepts. This video is our introduction, how to be a network engineer in a programmable age. In our next module, we dive into programming fundamentals and discuss data formats, APIs, REST APIs in Python. With that under our belt, we'll look at the newer network device APIs, both the standard technologies of Yang, netconf, and RESTconf, as well as the NX API that enables you to program your Nexus platform in an object-oriented, modern fashion. We'll move from network devices and into controllers and look at how we can get distributed control across our network, both with DNA structures like APIC-EM, in our data center with ACI, and even with the cloud with what Meraki has to offer you as you tackle the cloud and bring that into the network. We'll discuss application hosting, because network programmability is not just about configuration, it's about running code, leveraging your network as an application platform. We'll look at Linux features, Python, and even the ability to build and deploy entire applications, business applications, in the network with IOX. And lastly, we'll introduce the concept of net DevOps and how we can leverage configuration management across the network. We can use tools like Ansible to actually program our network just like we're systems administrators and application developers are programming the servers that run modern applications today. So in summary, we've gone through quite a bit in this. We've introduced the network engineer of old. We looked back through history at the network as well as network engineering. We traveled from the Stone Age all the way to the programmable age across the 4 ages of networking and seen the impact that cloud has had on IT. We ended with a consideration of some of the new skills a network engineer needs to have today and how the network programmability course will help you jumpstart your own journey. I hope you stick with me for the entire course, complete every module, every lesson. You can get all the code, all the examples that we'll run through across all of these lessons up on GitHub at github.com/cisco-devnet/netprog_basics. You'll want to join DevNet so that you can stay in touch with all the latest that's coming out. We've got learning labs and development sandboxes to help you hone these skills and learn everything you need to know about programmability in this era. If you have questions across your journey, feel free to come find me. I'm HAPresto at cisco.com on Cisco Spark as well as email, and HFPreston up on Twitter. You can follow me on GitHub at hpreston, where I'm constantly posting code samples, examples, and great use cases for network programmability. And be sure to follow Cisco DevNet on Twitter, Facebook, Instagram, GitHub, all over the place for the latest coming across all of what DevNet has to offer. Thank you so much for starting this journey with me. I look forward to seeing you in the next lesson where we'll dive into programming fundamentals. Thanks.